Hi and welcome back to my channel. This week's problem is the one you can see on the screen, and essentially what we've got is a chord of length 6 that splits the square in half, and we want to work out the area of the semicircle. Now, like I say, it splits the area of the square in half, so we've got this green area is equal to the blue area. If you want to have a go at this problem, what I'm going to do is I'm going to label the vertices like this, so that in your solution in the comments below you can more easily explain your solution. Now I'm going to start going through my solution in 3, there's an A there as well, bottom left in case you couldn't see it, 3, 2, 1. Okay, so hopefully if you wanted to go through this problem yourself, you paused the video by now. Otherwise, like I said, I'm going to go through my solution. Now the first thing that I wanted to do with this is we've got some constraints essentially. We've got some things that we're told. We're told there's a chord of length 6 and we're told that it splits the square in half. And so I've got a diagram here of one possible example, but obviously there will be loads of different variations of a chord length 6 across a semicircle that cuts a square in half. Now the one we've got is where it's cut the square in half with 2 trapezia. What we could do though is to simplify this problem by making it so that it cuts the square into 2 equal rectangles. Now that tells us a few things. That tells us that the width of the square, or the length of the square, is 6, so the width and the height are 6. Now that's a very useful thing to know. From there, what we can do, and what you probably should always do with anything to do with circles, is to put radii on there. So let's put the radii on our diagram like that. Now we've got an isosceles triangle there, so you might be able to go somewhere with that, but what I decided to do, and it's another fact that you should know about circles, it's a circle theorem essentially, is that if I put a line that would bisect my chord, that will be at right angles to the chord. So I was going to say a radius, it's not a radius because you don't have the top bit of it, but a radius bisects the chord at 90 degrees. That is a circle theorem. If I carried on up to the circumference of the semicircle, I would have a full radius there, but I've cut that top bit off because I don't actually need it. Now, the next bit of information that's important is obviously that line segment that I've drawn from the centre of the semicircle to bisect my 6 centimetre or 6 unit length chord. That goes up halfway of my square, so that is going to have a length of 3. Now then, I've got 2 smaller isosceles triangles, but importantly, I can now use Pythagoras to work out the radius r. So that is going to be 3 squared add 3 squared equals r squared, which we can simplify to 9 plus 9 is r squared, which is 18 is equal to r squared, which if we square root both sides, we get r is equal to 3 root 2. Okay, now from there, what we want to do, we've got the radius, we need to work out the area of the semicircle, and that's a half pi r squared, with our radius being 3 root 2. Next thing, simplify it. 3 root 2 squared is 18. We know that because we had r squared earlier. Half of 18 is 9, so we get 9 pi units squared as the area of the semicircle. I hope you enjoyed that problem. It's a quicker one this week. If you enjoyed it, let me know by dropping a like on the video. And if you found a different solution, I imagine there are several and multiple different ways of solving this problem, please put it down in the comments below, share with other people, share your solutions. Was mine the best way in your opinion, or did you find, in your opinion, a better way? Let me know down below. Thank you for watching as always, and if you haven't already, please consider subscribing to the channel. I will see you next Monday at 5 PM for another problem solving video. Thanks for watching, have a great week everybody, and I will see you, like I say, next week. Till then, bye bye. Wrong hand again, I do that every week. Bye-bye.